Imagine looking up at an alien sky only to see glowing, red-hot droplets falling rapidly from the clouds. But this is not water. On WASP-76b, spectral data suggests it literally rains molten iron. It is a world where extreme heat turns solid metal into mist, creating an endless descending forge. You cannot survive here, and the descent into the dark is just the beginning of the nightmare. Located over 600 light-years away in the constellation of Pisces, WASP-76b is an absolute monster. It belongs to a terrifying class of exoplanets known as hot Jupiters. These are massive gas giants orbiting impossibly close to their host stars. This extreme proximity dictates everything about this world's violent nature. It takes roughly 2 Earth days to complete a single, rapid orbit. Because it sits so close, the planet's rotation has been completely halted by stellar gravity. It is tidally locked. This means one hemisphere permanently faces the scorching star, while the other side is trapped in eternal, freezing darkness. It is a world of absolute, unyielding extremes, sliced perfectly down the middle by physics. The primary threat on WASP-76b is an unimaginable, aggressive heat. On the Dayside, directly under the relentless glare of its parent star, temperatures reach an estimated 2,400 degrees Celsius. Let that terrifying number sink in for a moment. That is hot enough to effortlessly melt solid iron. In fact, the extreme environment goes much further. The thermal radiation is so intense that it vaporizes heavy metals, turning them into a shimmering, toxic gas. There is no escaping this relentless heat. It penetrates deep into the gaseous layers of the planet. If you were exposed to the Dayside, you would simply cease to be, vaporized alongside the iron and magnesium floating in the alien sky. Physics always demands a balance, and on WASP-76b, that balance is incredibly violent. The staggering temperature difference between the superheated Dayside and the cooler nightside generates ferocious atmospheric currents. We are talking about colossal winds howling at thousands of kilometers per hour across the equator. These immense gales carry the vaporized iron away from the blistering light and directly toward the permanent night. Then, the planet hits the terminator line. This is the twilight zone, the exact border separating the eternal day and the eternal night. As the iron-rich gas crosses this threshold, the ambient temperature plummets. The sudden cooling forces the metallic vapor to condense rapidly. It transitions violently back into a liquid state. Models indicate that this process creates heavy, searing droplets of liquid metal. It literally rains molten iron. Suppose you tried to land a heavily shielded probe on WASP-76b. You arrive on the nightside, hoping the cooler temperatures offer a chance of survival. Instantly, your descent is violently battered by the supersonic iron rain. The molten droplets shear through standard titanium plating, transferring immense destructive heat upon impact. But as you sink deeper, you realize a terrifying fundamental truth about this world. There is no solid surface. WASP-76b is a gas giant. It is an endless ocean of thickening atmospheric pressure and swirling superheated elements. You are sinking into a planetary crucible. As you fall deeper, the crushing pressure begins to compress the surrounding gas, drastically driving up the temperature once again. The immense weight and internal heat of the gas giant's core would eventually crush and melt the remains of your vessel completely. Why do we dedicate resources to study a world so deeply hostile to life? Because WASP-76b offers a rare, invaluable window into the extreme limits of planetary physics. Astronomers cannot see the iron rain directly through a telescope, but they can read the planet's light. By using highly advanced spectrographs, scientists analyze the starlight filtering through the exoplanet's atmosphere during a transit. They discovered the distinct chemical signature, a barcode of light, for iron vapor on the evening terminator, but crucially, not on the morning terminator. This precise discrepancy strongly suggests the iron is raining out on the nightside before it can circulate back to the dawn. It is a brilliant masterpiece of deductive science. By decoding this faint light, we are mapping the complex weather patterns of a world hundreds of light years away. The iron storms of WASP-76b are visually spectacular, but they are also a grim symptom of a dying world. Orbiting so terrifyingly close to its massive host star, the exoplanet is caught in a slow, irreversible death spiral. The extreme heat is not just melting iron, it is physically inflating the planet from the inside out. The atmosphere is swelling, becoming dangerously less dense, and slowly boiling away into the cold vacuum of space. The host star's immense gravity is steadily stripping the outer layers of the gas giant. Over millions of years, WASP-76b may be completely devoured, leaving nothing behind but perhaps a scorched, dead rocky core. It is a monumental reminder that in the cosmos, even the most terrifying storms are temporary.